Every day, our lives are surrounded by advanced technologies such as smartphones, plasma televisions, tablets, and other electronic devices. We have access to various information and applications, and store data paperless, all thanks to these electronic devices, which contain hundreds of integrated circuits which operate specific features on the devices. Ever wonder how all these technologies came to work in the first place? The first revolution of integrated circuits can be tracked back to approximately 100 years ago. Back then, letters and the telegraph were the most common way of communication around the world, because not everyone could own a personal device. In 1904, John Fleming, a British electrical engineer and physicist, first invented the vacuum tube diode. The vacuum tube diode is a device which consists of a sealed glass tube that could control electric current between the electrodes through thermoionic emission. The anode plate then attracts those electrons emitted from the heated cathode plate. This creates a flow of electrons, also known as current flow, and completes the circuit. However, because the anode plate wasn't heated, electrons could not flow in reverse direction. This invention was inspired by Thomas Edison's light bulb effect, and this invention was also used for amplifying the faint signal from overseas during World War I, rectifying alternating current to direct current, oscillation, and switching purposes. This invention was the first breakthrough in the development of modern electronic devices. Over time, the engineers started designing complex logic circuits. These designs required approximately 18,000 vacuum tubes to operate. However, the cathode inside the tube would sometimes burn out and cause failures, in which the users had to replace the faulty tubes by themselves. In the 1950s, these vacuum tubes were replaced by transistors. Transistors were smaller in size, faster, and more reliable when compared to vacuum tubes. These transistors consist of 3-pin terminals for external connections. BJT has base, collector, and emitter terminals. During the circuit completion, the small amount of voltage or current applied to the base emitter terminal can cause current flow between the collector and emitter. BJTs can be used as high-voltage controlled current sources, current-controlled current sources, or a current amplifier. On the other hand, MOSFET has drain, gate, and source. Instead of applying current into gate, MOSFET relied on voltage to control the switching application between drain and source. The transistors were soldered through holes on printed circuit boards. This allowed engineers to develop advanced logic circuits for mobile devices, computers, and various portable devices. As the complexity of the circuits grew, the size of the components and production of these portable devices became a problem. Components being too big to fit inside computers, and the wires connecting the components were too long, causing the electrical signal not to travel fast. Finally, in 1958, all these troubles were resolved when Jack Kilby, an electrical engineer from Texas Instruments, invented the very first integrated circuit, also known as chips or IC chips. The IC chips were much smaller in size and compact, having several billions of transistors and other electrical components within the area of a tooth. There is no more wiring between discrete components, and the manufacturing process became automated. The IC is made up of layers of silicon oxide and metal layers to connect the components through masking on a wafer rather than relying on discrete components. As the technology advances, the IC chips get smaller, but still performing advanced complex logical operations fast, while consuming little power. The other advantage of using IC chips is that the cost of the chip is low, since it can be printed layers over layers through automation instead of manually contrasting a transistor at a time. The mass production and reliability of integrated circuits has revolutionized the age of microelectronics. It miniaturizes computers, portable tablets, and smartphones to fit on your hands. Even devices applied within space programs were made possible, all thanks to the integrated circuit.